Okay, I think it's 1:35. I think we're going to get started. Welcome to the Brainiac session. We have the smartest, the most amazing panel for you today. And we're going to go through those introductions. We want to make sure that you know that this is interactive. And so you should have cards that you can write questions, and I will get the questions, and then I will use my poetic license as the moderator to merge them together so that we get to as many of your brilliant questions as possible. So please don't hold back, because we don't get this kind of panel together very often on probably one of the most more discussion on artificial intelligence and machine learning as a technology than I have ever heard another technology more broadly discussed, right, across government, industry, and academia. So this makes it a pretty special panel. So without further ado, we're going to get to the introductions. First, we have Mr. Brett Vaughan. Brett is a career cartographer, geographer, and national security and an environmental science professional. He is currently the AI portfolio lead at the Office of Naval Research. He has spent the majority of his career at the National Geospatial Agency, but working forward with customers across defense intelligence, focused on scientific and technical development and concept innovation. Next, we have Dr. Matt Gaston. Matt is a career computer scientist with a focus on technical innovation and intelligence analysis. Matt is currently the director of the Carnegie Mellon Software Engineering Institute Emerging Technology Center that he established in 2011. Previously, he was the director of research at VIS, at GDC4 Systems, and a technical director at NSA in the Advanced Analysis Labs. Next, we have Jason Matheny. Jason is an applied economics PhD and MBA, the founding director currently of the Center for Security and Emerging Technology at Georgetown, which he established about a year ago. And previously, he was the Associate Director of National Intelligence and the Director of IARPA. And he is a member of the National Security Commission on Artificial Intelligence. And then last but not least, we have E.P. Matthews, who stalwartly is filling in for the CIO of DIA, Jack Gumtow, who literally had to back out within the last hour. So you're an amazing person, first of all. He is currently the chief of end user services at DIA, which is basically all the stuff that any of the analysts or collectors use. And previously was on a joint duty assignment at NSA in enterprise analytics, and was also worked at Bell Atlantic in wide area networks. And so with that, please give a warm welcome to our panelists.
Thank you.
So truth to be told, I took my first artificial intelligence course in the mid-'80s. The focus back then was on how much could we do to help analysts with phase one analysis, right, which was processing, and phase two analysis, which was correlation, so that analysts could do third phase analysis, which was, right, prioritization and teeing up of those most likely options to a decision maker. The beauty is it's evolved fast and furious. So what we're going to do is we're going to start out with each of our speakers giving a 5-minute perspective of artificial intelligence from their current mission set and their current background. So with that, we're going to start with Brett.
No pressure. First out of the gate. Thank you, Terry. On behalf of Chief Naval Research, I want to thank you and INSA for having us here. As Terry said, I grew up first part of my career in intelligence, so it's like coming home here to this forum. For the last decade, I've spent in Navy science and technology, and the last 2-3 years of that have been dominated by AI. And that is now my full-time job. So everyone should know, and if you don't, I want you to know that the Navy has been very active in AI for decades. We've been a long recognized leader in the science and technology of AI. Our expertise center of gravity is right down the road, about 2-3 miles, at the Navy Center for Applied Research in AI at the Naval Research Lab. Wicked smart individuals. They were key players, and they helped draft the national AI policy, the DoD AI strategy, and just a fantastic group of folks. That's the good news. The bad news is our current AI challenges in the Navy are less science and technology and more issues of adoption and adaptation. And that's where I'll focus most of my comments now and later. The potential for AI application in the Navy is quite vast, almost infinite. Pick any job, mission, function, task. There's a bit of potential there. The key question becomes, where do we place our bets? Where do we focus if you're talking about something as complex and as technical as AI? So that is driving us, where do we focus our time, our energy, our money, our resources? And what we've learned recently is in necking down in those meaningful areas, strategic frames become critical, very important. And I want to talk about just 2 of those real quickly here. Frames of lexicon and frames of adoption. For the lexicon piece, we learned over the last few years, as AI has exploded in the commercial sector, seeping its way into our world, that your definition of AI matters and the way you describe the AI landscape matters. The Navy adheres to the Oxford Dictionary definition of AI, the theory and development of computer systems capable of tasks that are normally associated with human intelligence, computer vision, natural language processing, machine translation, etc. Beyond that, those smart people right down the road have also developed a Navy-unique AI taxonomy. 8 areas or types of AI that we are interested are compelling to the Navy, and we are in pursuit. They are reasoning, cognition, perception, machine learning, coordination, collaboration, knowledge representation and management, and planning. The last frame I want to talk about briefly is adoption. Again, where do we focus? Where do we adopt? Adopt is about the what. Adaptation is about the how. So where are we going to place those AI bets? You will find, if you come to my office, that the areas we are working on now are really functions of 3 things: priority, technological opportunity, and a unique Navy need or challenge. And that's really where we're centered today. There's more, but I'll cede the microphone to my esteemed panelists. Go from there.
Okay, that was a fabulous framing. Thank you so much. Hey, Matt.
Okay, so thank you, Terry, and INSA for having us. It's an honor to be up here with the panelists. It's a great group. So I feel really lucky to be here. I come from a university now, so Carnegie Mellon University. It's a pretty amazing place to be. If you're interested in artificial intelligence, it's arguably one of the places that was most involved at the inception of that as an area of study or a field. Famous people like Alan Newell and Herb Simon from the very early days. I think Herb Simon's book was The Science of the Artificial. It's worth a read if you haven't read it. So it's really great to be at Carnegie Mellon University. Not only am I at Carnegie Mellon University, but I'm at the Software Engineering Institute, which has been responsible over the last now nearly 4 decades for maturing the engineering discipline around this amazing thing we called software. 40 years ago, the Department of Defense realized that software was going to be important, realized that it was hard and had a lot of challenges, and created the SEI to help understand the discipline around the engineering of software and mature that discipline over time. What's exciting right now is that I think the same thing is happening in AI, right? AI has been around for decades. The Navy's been involved for decades. I know in my professional career, I've been doing AI for national security for nearly 20 years. As far as an engineering discipline is concerned, though, AI is still a craft, still a black art at times. Amazing people doing amazing things with AI, and in some cases solving some engineering challenges, but not getting all the way to a mature discipline where we can reliably build, design, build, use, integrate, evolve these types of technologies. And so my 2 main points in the introduction, because I actually prefer the questions section of these panels, is that AI is not machine learning. Machine learning is part of it, but there's a lot bigger scope. I actually like the Navy's framing where there's 8 areas. I've seen a bunch of other framings where there's 10 areas or 12 areas. I know at CMU we have an entire stack of AI technologies that we think about, all the way from the compute level up to human-machine teaming and autonomy at the top. So when you think about AI, know that it's not just machine learning, and when you think about machine learning, know that it's not just this amazing technology we call deep learning right now. That's the very popular and rapidly adopted technology out there in the world. There's a lot bigger puzzle there. When you look at DARPA and the third wave of AI that DARPA is promoting, it's the combination of statistical techniques like deep learning with higher level reasoning techniques that maybe were of old that we can now scale, and mixing those two together to get advanced capabilities. The second main point is that AI, there is a need, I think, in the world for an engineering discipline around AI. We're rushing very quickly to capabilities. When it's a recommender system for a movie or a book, it's not very life critical. I like to make sure I get good books to read. But in other applications, we have life critical decisions that are going to get made, and we need to know how these systems are going to operate, how they might break. What about the data that goes into them, and whether that data is correct or accurate or not filled with bias, these sorts of questions. And so I think there's a whole span of engineering challenges around AI that need to come along with all of the research and amazing capabilities that AI represents. And so with that, I'll turn it over to Jason.
Okay.
Or back to Terry.
You got it, Jason.
Great. Thanks, Terry. It is such an honor to be here and to see so many of my heroes in the audience. I really feel privileged to be here. I left government after 10 years in the intelligence community to set up a policy and intelligence shop housed within a university that can provide free policy analysis and intelligence analysis to the government. So it's an awesome gig. And I really do want to make sure that everybody here knows how to reach us so that if you want analysis of what's happening globally in AI, you can reach out to us and get our assessments. So if you go to policy.ai, you can find us. We have been looking a lot at the sorts of trends in AI research and development funding, and I want to mention 3 trends that I think are especially important. One is just how much the R&D ecosystem in AI really depends on U.S. federal funding, and places like ONR and DARPA and IARPA are addressing the kinds of research challenges that the commercial markets will not address themselves. To bring up some examples from IARPA, since I see one of my great colleagues, Seth Goldstein, in the audience, Seth's program at IARPA is looking at how to combine human judgments and machine learning in order to make more accurate geopolitical forecasts. That's not a problem that the commercial sector is going to take on. And if you look at other kinds of problems like interpreting satellite imagery, intercepted SIGINT, speech, text, video analysis with security events happening within those media, those are things that there aren't going to be well monetized markets around. So we really do depend still today on federal R&D to close the gap on those market failures. The other area where I think there's enormous need for federal R&D as well as IRAD from industry within the national security sector is in addressing AI security risks. And Matt touched on this, that a lot of the techniques that are used today were built without intelligent adversaries in mind. They were sort of innocent. And in some of the same ways that we're now retrofitting most IT systems with security measures that are meant to address vulnerabilities that were baked into systems in the 1980s, or earlier in some cases, we're going to have to start baking in security from the start with AI unless we want to spend billions of dollars retrofitting security years from now. I'm going to give 3 examples of those kinds of vulnerabilities. The first are adversarial examples, which is a technique that an adversary can use to confuse a classifier into thinking that, for instance, an image of a tank is instead an image of a school bus or a porpoise. So it's a way of creating sort of an optical illusion for a machine learning system. A second kind of vulnerability is something called a Trojan, in which you introduce a change into the environment in which a system is learning so that the system learns the wrong lesson. And Jeff Alstad at IARPA has a great program called Trojan AI, looking at how to secure against attacks like Trojans. A third vulnerability is something called model inversion, in which you can reverse engineer the training data that's been used to create a machine learning model. So if you have a bunch of classified data that's going into a model, you really should be protecting the model itself, even after it's been trained, at the highest level of classification that the data used to train it. That's not always done, by the way, so please be careful with your trained models. It's a little humbling that less than 1% of the AI R&D funding is going towards these areas in AI security, and I think we'll need to increase that. We'll need to increase not only the investments that companies and universities and federal R&D agencies are making in these, but we'll also need to develop national test beds for testing systems against adversarial attacks with intelligent adversaries in mind, so that 20 years from now, we're not trying to retrofit all our systems with security.
Thank you. Thank you for the opportunity. It's just amazing sitting here, what a small community we are. I get to see Ms. Long. Thank you for your leadership at DIA. For those who don't know, she was the deputy director. And I quickly learned about the value of data, working under you. I don't know if you remember this. One of the projects I did for you was, hey, how do I increase female retention at DIA? More than a decade ago, so I don't know if you remember that, but very thought-provoking questions, and it helped me learn a lot on the focus on the data. The other piece is, as Jason and I were talking, we didn't realize that we were in the same building, working just in a fairly small building, working just 2 floors apart for multiple years, and we get to see each other. So we're a fairly small community. So let me talk from an IT perspective on the one of the things that we're really looking, to solve with AI. So at DIA, your AI for us is still at an infancy stage, right, in terms of adoption. I think you talked about that in adoption. So things that, we're really looking at 4 or 5 things. And I also want to state, if you have ideas in where you could help us, we look forward to that. So I think the big things we're looking for is, can I make sense of the data within either internal within the same data set or external with multiple data sets? Can I make sense of this data? Right now, can I find a correlation where a human would not even think of asking? And we've seen, as we have started to adopt in small cases, then we're starting to see the advantage that AI brings to us, right? And so things that we would not think about in the intelligence community, we're starting to see, starting to find correlations that, a human would not even normally think, or an analyst would not normally think. Can I make an assessment on this large data, right? Large amounts of data just goes untouched. We just don't have the manpower to look at all these things and make assessments at all this. Can I make an assessment of this large data? At least to a point where I can say, you guys an analyst needs to at least look at this. I think that's another area that we're looking I think the advantage with AI for us is we recognize that, leveraging these capabilities is now we can start to do this at human speed, we can leverage and do this at machine speed rather than human speed. And that's all the difference is, right, between writing an intelligence report versus writing a history report. And it is that time. And lastly, I think the one thing we have noticed is, there's a tremendous growth in volume, velocity, in terms of data that is being available to us. Most of this data is not human generated, it's really machine generated. Does it not make sense for us to leverage the machine to look at machine generated data, right? And so what are some of our challenges, right? How do we work with analysts to quantify either known bad behavior so that we can look for that, or known good behavior so that we can look for the anomaly in that behavior? So these are some of the things that we are starting to look at. I really can't speak in the mission space, so I'm going to focus more on the business space, so like on the back-end infrastructure type things. In terms of, if you look at the infrastructure capabilities, so routers, switches, desktops, servers, all these tools are COTS-based products. All of them, you can start to leverage these tools to identify when things will go down, when things will break. You can get to reliability-based maintenance where you know that something's going to break prior to it breaking, right? We can start to move from descriptive analytics. And right now we are mostly in the descriptive analytics space, right? So I know after something breaks that something broke. A dashboard or some customer that calls me and tells me that something broke. Well, how do I move that from a descriptive analytics into predictive analytics? And some of the challenges that we are having is understanding the data, understanding the service decomposition that, a customer will say SharePoint is down, but it's not really SharePoint that's down. It's really one of the subcomponents that make up that service that's down. How do I put those things together? And then once I get to that, then how do I leverage, prescriptive analytics and machine learning? So this is where we are in our journey. We are watching industry. Love to use your help. Made a decision advantage.
Okay, I think you now know that there's no question you can throw at us that we can't handle. So please be thinking of those questions. So what I thought we'd start with, because I love solutions and initiatives, is you all spoke a little bit of framing from your perspective. Are there particular initiatives that you're working or that you know of, especially in the national security arena, that we might want to share? Some national security framing. Obviously, we had the executive order from February of this year about U.S. leadership in AI and the standards, workforce, R&D area. We have the Department of Defense AI strategy for 2019 that was, just on the heels. We have the Joint AI Center, right? That's, just reaching a center of mass. And then we have the IARPA DIVA initiative. I think it's pronounced DIVA. Okay, thank you, because that's how I would think of it. And then we also have needs, right? What are some of the foundational needs that you have to have in place in order to have an AI capability? The bandwidth, the solid state storage, the curated data, the interoperability. So we can start with any of you on a current initiative that either you're working or that you're partnering on. Who wants to start?
I'll go.
Okay.
So there's really there's three that I can talk about, so I will. Two of them are applied AI efforts. One is more basic research or science of AI related. The two applied, well, I'll go back. So if you look at where we have invested largely today, you see AI, at least for the Navy, employed either as an aspect of autonomy in an unmanned system or a decision aid or stripe of decision aid that's intended to increase efficiency in an information-saturated environment, to help the human out. So decision aids or AI that supports some level of autonomy in an unmanned system. Both of those parent groups, you can drill down and envision environments, and I'm going to talk to two. One is human on the loop, one's human in the loop. Many of you are probably familiar with those terms that we're working on that help meet challenges in both those conditions or incorporate degrees of autonomy or decision aids. One is more focused on command and control in the Navy. It's more focused on the human and the human-machine partnership. This is our human on-the-loop example where we're pursuing. If you think about some of the strategic documents that have come out in recent times, distributed maritime operations, if you think about the complexity involved with the number of ships, vessels, and entities that need to flow into an area of operations, accomplish a mission, flow out, be supported, one can easily envision where it might be helpful to have the help at machine speed of a recommender or some other decision aid. The other instance is more the human, I got that wrong. That was human in the loop. This is human on the loop. So the other, think a very congested electromagnetic spectrum environment where threats, information are coming at a human at volumes and velocities that will quickly subsume the human. This is the human on the loop. Real time, you can easily envision an instance at sea where a ship might be threatened from many vectors, and decisions need to be made very rapidly. Those are the two applied efforts that are a significant part of our portfolio right now. The one, science of AI, goes back to the more basic research and is starting to scratch at the computational intelligence, the fundamentals of that human-machine relationship, scalability. Where does scalability break? How can machines and humans work better together? How can each recognize that the other partner is receiving properly, understanding the more sophisticated nuances of that relationship? And then the last thing I'll say is on the needs, we in the Navy are very focused on what I'll call, and I've seen in articles, the AI ecosystem approach. So we start with a problem, and then we drill down beneath that problem to determine the relevant ecosystem, the data, the technical infrastructure, the training, the expertise of the people. All of these things are important factors in building a healthy ecosystem in which to drop an AI algorithm. Deficiency in any one or several of those could spell disaster, failure for that piece of AI. So when we come at an AI challenge or problem, we are coming at it very problem-specific, context-dependent, and mindfully aware that we have a whole set of underpinning conditions that need to be considered as we scratch away at that.
It's a great framing. Thank you so much.
I already mentioned this sort of, it's not an initiative or a program, but a movement to create a community around AI engineering specifically for defense and national security. So I won't belabor that. I will say we're looking for partners, interested parties, anyone that can help with that. A couple of things that I see that, again, maybe aren't initiatives or programs, but they are activities that are out there. I've seen some pretty exciting things happening out of DoD with support from the intelligence community with open data challenges. So the curation of very large data sets, labeled data sets in most cases, where we can get sort of the world of innovators out there to look at problems that are related to mission capabilities without telling them specifically what those mission capabilities are. I think of the XView challenge out of DIU, I think in partnership with the JAIC. It was satellite imagery. The challenge was to automatically localize on objects in satellite imagery and then automatically classify those objects. down to a very fine level of detail. From satellite imagery, can you tell the difference between a pickup truck and a flatbed truck, right? Pretty hard problem to do, and that was an open data challenge. There's a second XView challenge called XView 2, novel name, on the HADER project, the HADER topic, humanitarian aid and disaster relief. They're creating a global data set of natural disasters where they're labeling buildings both pre and post disaster, classifying it by the type of damage and the severity of the damage. So is this a flood? Is it water damage? And is it totally destroyed? Or is it a fire and completely gone? Or just barely burned at all? So it's really interesting, and why I think that's exciting is it's getting so many people to focus on these problems, and then their solutions are shared with the sponsors of those challenges. So that's really exciting. Related to that is there's a trend out there in the world, right, academia and industry and possibly even government, on the democratization of AI, more specifically machine learning. You're seeing companies, even Microsoft has released recently a visual drag and drop tool for building machine learning applications. So that means any of you could go off and build a machine learning capability this afternoon if you wanted to. I know my son, who's 13 and hasn't taken a programming class, has tinkered with some of these technologies. That's both a very positive thing. It will promote understanding and help people know what can be done with these technologies, but it also opens up a lot of these questions about, well, what if they don't do it right? What if these things get deployed too soon before they're ready? Those kinds of things. And then the last thing I'll mention, because we have a view of it from CMU, DARPA has a program called Software Defined Hardware. And the motivation for that program is a bunch of machine learning, AI, graph processing, smart computational workflows that are really being used to push the hardware vendors to innovate when it comes to hardware technology, computing technology. And while I don't always think of the compute layer when I think of AI, to get to the point where we're doing mission scale, mission speed, the hardware's got to come along as well. And so there's a lot of exciting things happening in that community that I think shouldn't be overlooked when we're thinking about AI.
Okay.
Great. I'll talk about other people's initiatives that I'm really impressed by. The first is the White House budget priorities that call out AI, the NDAA that calls out AI. I mean, this is clearly a budget priority, and I think we have seen a pretty significant increase in federal funding for AI over the OMB tracks from 2015 to 2018 suggested about a doubling of funding, and it's likely to double again. Other efforts that I've seen that I've been really impressed by are coordination efforts, things like the White House AI R&D strategic plan, which I think provides a lot of good fodder for industry and academic researchers to identify the most promising areas of research. The partnership on AI, which serves as a consortium for industry leaders in AI research, as well as the National Security Commission on AI that I serve on. I'm so deeply impressed by the quality of the commissioners and the staff and the amount of work that they're putting in to help advise government. On the R&D side, the things that I've been really impressed by is the continuing portfolio of research at ONR that historically has been so important in laying the foundation for deep learning. I mean, we owe such a huge debt to ONR. DARPA's AI GUARD program looking at AI security, IARPA's Trojan AI program looking at AI security are, I think, filling vital needs that we have in industry and academia. And then thinking about the inputs to AI, the four main inputs are human talent, algorithms, data, and compute. And I'm really quite bullish about the US leadership in all four of these areas in ways that are relevant to national security, but particularly in two of these areas. In people, the United States continues to attract and frequently retain the best and brightest computer scientists who come here to study and later decide to live and work here for the rest of their lives. So doubling down on that advantage that we have, that's a comparative advantage for the United States culturally and historically, by making sure that people can immigrate here and contribute to our economy is, I think, a real key policy need. A second natural advantage that we have right now is in the area of computing. We have a pretty strong advantage relative to our main competitors in being able to design and fabricate leading edge chips for machine learning, GPUs, as well as machine learning ASICs. And I think that's a really important strategic advantage that we should maintain. We, along with Japan and the Netherlands, also control about 80% of the market for semiconductor manufacturing equipment. And this really is such an important input into everything else that drives the future of machine learning. The one area I want to highlight that I think that we're weakest in and where there might be really big bang for the buck by making some investments is in test beds and benchmarking. We really don't have a great way currently of measuring the performance of machine learning systems across a variety of operational data in operationally realistic conditions, seeing where they break and how they break when presented with novel attacks. We also don't have a great way of benchmarking the performance of foreign systems. The best work that I've seen comes out of the AI Index that's co-published by Stanford, as well as the MLPerf site, which does benchmarking tests of machine learning chips. But I think that's an area where we really need to invest more.
You don't have to.
Okay.
It's only if you want to.
So I can speak on some of the initiatives that are needed for us at DIA to get to that, to get to this level. Again, speaking specifically on adoption. So a big initiative for DIA is MARS, machine-assisted learning. Our lawyer came specifically and said, do not speak on this. So I will not speak on that because of the acquisition process that we're going to go through. But you can Google it and you will see it. And it's a big effort and one of our top priorities for our director.
Also, it was spoken to at your recent conference, and
Yes.
so there is some information out there on it.
Yep, it was spoken. Yeah, it was spoken at the DOTUS conference.
But
yes.
it's MARS, correct?
Yes. MARS. But how do we get to that level? So that is one big initiative. So one of the things that we see as a challenge is that everyone comes to the IT folks. Hey, I want to do artificial intelligence. I want to do machine learning. I want to do these things. And we have no clue how to do it because what we're missing is that vertical domain expertise of an analyst, right? So we can do IT-related things. So I can pull data, I can decompose data, but I can't do like what the data standards should be. What should be the data classification? I don't know. Because I'm not partnered with an analyst, I don't know what necessarily the analyst is looking for. Like, how do I get that known bad behavior? And so in order to achieve that, one of the things our CIO is doing is he's really proposing a shift in terms of creating like a pyramid. And this was pyramid. He showed this pyramid at our DOTUS conference recently. And what he said is, hey, I'm going to focus on the core infrastructure services that enable machine learning and artificial intelligence. And I really want our mission partners, so that is the DI and the DO, right? I want them really to focus on building the analytics and the visualization of those capabilities. And they're going to be a place, of course, a hybrid where that's done in partnership. And I think for us, this is a seismic shift because, you had the IT folks here. As we went through budget cuts and sequestration, in order to gain efficiencies, we had consolidated all the IT into one, and we saw significant gains of efficiencies. But as we start to move into the ability to leverage data, we, in DIA and in other organizations, we really have to partner with our mission partners so that we can leverage those capabilities, right? So beyond beyond the initiatives that were spoken to, right? What are the things that we need to do at DIA? So one of the things that we're looking to do is how do we shape the workforce to achieve this? Because the people we've hired are not necessarily people who are experts in this. And this also, when you look across the directorates, this is not exclusively a CIO or an IT problem, but really it is how do we collectively as an agency solve this, right? So maybe there has to be a shift in terms of data swimmers. There's not an exclusive knowledge within IT, but within DI and DO, or S&T, or science and technology, and different directorates. And how do we might have to move from hiring just political science analysts to people who are electrical engineers or system engineers and train them on the tradecraft capabilities. And so those kinds of shifts are what's taking place that previously, we didn't factor in because we need that domain vertical expertise that, and to be partnered with the IT expertise. I think the other aspect is in terms of shaping the workforce, one of the things our CIO has said is, hey, he wants to hire 80 to 85%, people with STEM backgrounds. And so these are the kinds of some of the internal initiatives that, in terms of shaping workforce, culture changing, partnering across and outside CIO. We're looking to partner with academia and send people to academic institutions from our organization for a year or two so they can see and learn things that we cannot, and bring those standards of excellence internally. And so those are some of the things that we're looking to do in addition to the mission initiatives mentioned earlier.
Okay, thank you so much. Several of you brought up adoption culture, and frankly, having my own company that leverages and partners with over 250 AI and machine learning commercial companies out there today, I actually find culture and adoption when I'm meeting with industry customers or government customers is often the biggest hurdle. So as development and research and transition folks yourself, what are some of your ways of getting them to think differently about the risk of AI algorithms, the risk of commercial AI capabilities and tailoring those, the importance of different ways of OTA, RFPs, other ways of piloting and transitioning and doing it more quickly? And just any takeaways on how to promote that adoption? Anyone want to start? I didn't mean to make it so hard.
I'll go ahead.
Okay.
Last time.
And we can just do one or two responses and move on.
So I talked about adoption and adaptation, and in the question I heard more adaptation, and this is critical. To be effective in the AI space, there really is going to be a necessary series of shifts made in business mode, in development, in delivery. And those shifts have a very unique nature and velocity compared to what we're typically used to. So how I make it compelling when I'm talking with someone, and go back to what EP said about the domain expert, that's absolutely vital and critical. And I try and draw a relation to something or a scenario or a condition that they would be familiar with, and make the distinction that way. But in our, there's a great article I would point everybody to. I'll give credit and permission to Dr. Chris Demchak at the Naval War College. Her article, The Four Horsemen of AI Conflict. She does a very good job of describing some of the dynamic forces in play. And those forces, if you embrace them and master them, you will find it much easier to effectively adapt and make that adaptation. If you ignore them, you do so at your own peril, and you will probably be trampled underneath. Her four horsemen are scale, speed, strategic coherence, and especially for this group, sine qua non of strategic power is foreknowledge. I've recently talked to her about this, tweaking her intellectual conceptual model for the Navy's use. She gave me permission. My four horsemen of Navy AI are scale, speed, coherence, and resilience. And that resilience piece is, when I talk about that ecosystem, we've talked about adversarial AI and things of that nature. How resilient is the thing you've created, that very fragile ecosystem? Is it resilient in the face of either environmental or technological degradation and conditions? Is it resilient in the face of malicious intent or otherwise, bad actors trying to mess up your algorithm? But I think, adaptation is huge.
Okay. I'm going to switch gears. We have a couple of questions about, where do we think China is on AI? Where do we think Russia is? Europe? So I thought I'd go to the two folks who are in the middle who have interaction with foreign students, foreign research, Do you have a sense of where those other peer competitors are vis-a-vis us?
So Russia, I think what's most unique about Russia is its risk tolerance for fielding systems quickly that haven't been tested very well. And so that means there's a whole lot of misadventures out there with weapon systems. I think the overall quality of AI research in Russia is very low. It's not in the top 10 globally of talent. It just doesn't do well on any of those four measures of capability that I mentioned, people, algorithms, data, or compute. But it does show a willingness to field systems, perhaps before some of its competitors. China is a much closer competitor to the United States. By some measures, it maybe has 1/3 or 1/2 the capability by various kinds of schemes of looking at the quality of research, the impact of the research. But it does have ambitious plans. It's very hard to tell how much of those ambitious plans actually translate into real funding and funding in good research, as opposed to good money chasing bad and some of the so-called chosen national champions, the Baidu, Alibaba, and Tencent companies, which aren't always especially cost effective in their research enterprises. They have a very hard time attracting immigrants. They have a hard time even attracting their own human talent. And many of their best computer scientists come to the United States and want to stay here. A recent analysis by Macropolo showed that of the computer scientists with Chinese affiliations that were accepted into NeurIPS, the sort of leading deep learning conference, about 75% of them were no longer in China a few years later. So really there is a potential for a massive brain drain from China out to other centers of AI research like the United States, Canada, and the UK. And we should be leveraging that. We should be doing everything we can in order to help encourage that brain drain so that we doubly advantage ourselves by having that brain power and also costing our competitor from losing that brain power. In microelectronics, China is also behind. SMIC, which is their largest indigenous foundry, is several nodes behind the state of the art. It has a very small supply chain relative to others like TSMC or even a place like Global Foundries. So we really do have some, I think, substantial advantages. China, though, can catch up. So even though I think the United States has a strong lead, we can't be complacent. We have to make sure that we are investing in R&D. We have to make sure that we're maintaining competitive markets so that we can draw on one advantage we have. We need to make sure that we do capitalize on our ability to attract and retain the world's best talent.
I think Jason actually nailed it, so I won't say much more. I will mention that I've been to there's a big conference in AI called AAAI, or the Association for the Advancement of Artificial Intelligence. And over the last 3 years, both participation and number of submissions from China have been greatly increasing. This year, I think more than 50% of the submissions came from Chinese universities. The observation that I have is that the acceptance rate of those papers is still lower than acceptance rates from, say, U.S. universities or other countries. I actually think Italy, strangely enough, has the highest acceptance rate, but very few number of submissions. So I think you're seeing a rise of activity in China, and the quality, while it's not maybe at the level of what we're seeing out of U.S. universities, it's creeping upward, right? Over the last 3 years, that submission rate or acceptance rate for Chinese publications has been growing. My caution here in the national security community is AI and machine learning is definitely an international discipline, a global discipline, and there's innovation happening everywhere. So while it's important to keep our advantage over the rest of the world, and maybe limit or maximize the brain drain, depending on which side of it you're on, we still have to pay attention to the whole world. There's a lot happening out there that's valuable in a lot of different sectors of the economy, the defense and national security space, et cetera.
Okay, thanks so much. Those were great perspectives. We only have about 10 minutes left, so I wanted to do one more question and then, all right, no, I guess we've got more time. It's 2:45? Okay, sorry, we have more time, never mind. This is a question I would ask, but someone else is asking it. What are the best ways for commercial AI solutions, and they underlined real AI solutions, to get in front of your respective organizations or to partner together? So how do they get in front of you folks?
I think for us, it definitely starts with education. So one of the things that we are looking to do is to not just educate the IT workforce, but also educate the organizations to the left and right of us, right? I think one of the things I noticed when I was at NSA is I have system engineers, I have software engineers, I have electrical engineers in their version of, it was not exclusive to the IT organization. It was across. You don't see that at DIA, right? So I think that it starts with that, right? How do I change and shape the workforce so that everyone is a data swimmer? I think the second thing is a cultural change in the adoption of risk. So for me, on the business side, it's okay for me to take a risk because I'm looking for a decision advantage. When I talk to my mission partner, they make it very clearly, hey, I'm talking about, warheads on foreheads. I cannot be wrong. And I cannot guarantee your algorithm, right, when they're referring to not me specifically, but they're referring to the AI algorithm. If you cannot explain it and articulate how you came to it in terms of the rational use behind it, they don't trust it because it's a reflection of their brand, right? And if think of this in such a way, hey, DIA put out the wrong intelligence, it affects the brand of DIA. So if you want to use real AI, I think it's the education and the analysis of how you got to that secret sauce so that you can create that decision advantage. I think that's what's missing for us.
Okay, thank you. Brett, how do folks get in front of you? or your organization?
Sure. So I'd say the first thing you do, I mentioned the Navy AI taxonomy. You get a hold of that and at least become familiar with it at a high level and think back where you come from and how you think you can help advance any one of those areas. It's out there on the internet. If you Google Naval R&D AI taxonomy or Navy AI taxonomy, you should be able to find it. If you can't, you can tap me on the shoulder and I can provide you a copy. It's publicly releasable. We regularly, of course, put out announcements in Fed Biz Ops and BAAs. We have one coming out soon related to the science of AI I talked about earlier. We have a small business office. Those are great folks. They're always good to engage if you're interested in talking. We're starting to get better about the more non-traditional and agile acquisition vehicles, the OTAs, the IDIQs. We're seeing that more often. We're starting to ramp up engagement in consortia. That we're seeing a lot of good work come out of those groups. And for AI in particular, there are several Navy entities or activities that could allow you access to the right folks and to key Navy initiatives. And the one I'll mention is the Cruiser outfit at the Naval Postgrad School. Cruiser is an acronym, the Consortium for Robotics and Unmanned Systems Engineering and Research. It's open to industry, government, academia. Anyone can join. They have a regular drumbeat. It's a great way to just open the door and see who's working on Navy autonomy and AI issues.
Okay, great, thank you. So I'm combining several questions, but the whole focus is on, to what extent is AI wholly dependent on the optimal infrastructure? And so other parts and pieces to that is, I'm sorry, but I'm just going to phrase it, how does cloud computing play in? What is the next big hardware innovation, that is foundational to AI? And really, what is the ideal infrastructure platform today for AI? And is there something coming around the corner that's that next piece? Matt, you want to start out?
Briefly, there is no ideal. It all depends
Okay.
on what you're trying to do.
Okay.
I'd say the same thing, right? When I go and talk to companies or government organizations, they say, give me some of that machine learning, or give me some of that compute environment for doing machine learning. The question really is, what's the problem? What's the mission capability you're after? What's the data you have to make decisions? So always start with the problem. I think that's really the only answer I'll give here, is that there is no ideal, there is no perfect. Yes, cloud computing can be used, should be used for various applications. There is exciting things happening in the hardware space. I can't remember the name of the company, but there was a chip that just came out that's 1,000 times faster than a GPU or something like that, packing more and more compute into a single chip. So there's always innovation happening. Don't strive for ideal, strive for what works for your problem, and then always be on the lookout for new technologies coming along the line.
Okay. Jason?
Yeah, I think hardware is so interesting how rapidly it's changing. A recent analysis by OpenAI suggested that the amount of compute that's being used in leading-edge AI experiments is doubling about every 3 months. So the hardware space, I think, is likely to be really exciting over the next decade, and whether that's means increased improvements in GPUs or machine learning ASICs or FPGAs or cryogenic computing, or quantum accelerators, or all of the above, I think it'll be very hard to predict which of those combinations of hardware innovations are likely to be dominant, if any of them will be dominant. It might just be a fairly sort of openly divided infrastructure. I think the most important infrastructure, though, is the geopolitical infrastructure. And the biggest advantage that the United States has in global leadership is its global alliances with the other leading countries in AI, countries like the UK, Canada, South Korea, and Japan, and maintaining those alliances both so that we can share talent, we can share data, we can share innovations and compute. I think that will end up proving more valuable over the long term than any specific innovation in infrastructure.
Okay, great. So we want to do, closing remarks across everybody, but there's one question that keeps coming up, which is, what are those first couple of steps that you have to take if you're a non-big budget IC entity? So let's say I am not using AI today. I have an important intelligence function. How do I get started? How do I get those foundational pieces in place? What are the questions that I need to be asking as that point of departure? So if you want to do that question and then wrap in your closing thoughts, that would be awesome. Brett?
Okay, I'll steal Matt's thunder because he said it well. From our perspective, it all starts with the problem and problem curation, getting good fidelity on the problem you're trying to solve. And then I would grab your nearest and dearest AI expert and look at the scope of AI tools and techniques that are out there to start a meaningful and impactful road to effective AI. But problem curation it's becoming, I think all the services are becoming acutely aware of how important and difficult that can be, but it does start with the problem. It does not start with AI. And in wrap up, I'll just say that know that the Navy has been active. We are making a shift, more concerted effort on adoption and adaptation to build on our recent success in the technology and in the lab. We do believe there's a wealth of capability in the lab environment that is ready to go into the field, and experimentation and prototyping, that was mentioned as well. We know that's going to be that should be a priority, and we're going there. And that, for me as a Navy employee, there are a lot of people wringing their hands about AI. I'm not one of them. I feel duty bound to put the most advanced technology in the hands of our sailors and Marines to protect them and to make sure they can do the most efficient job, whatever it is, whether that's at sea or in the back office. And I see a tremendous potential for AI to help in that regard.
Okay.
So thank you.
Before we continue, thank you. I just got hit upside the head again that we didn't discuss ethics in all of this. So if, as we go down, you want to weave that in, you're more than welcome to do so, and we can circle back with you, Brett.
You don't have to.
So, okay. But if you want to not deal with that one, that's good too. Who would like to go next?
Can go. Yes, Brett said, reiterated, start with the problem. So assuming on getting started with AI, if you're not a big budget IC agency, if you have the problem, that's a great start. And also assuming that you have access to data and access to compute, because solving those problems is not really a technology problem. It's being able to access the resources that are available to you. And then from there, I would actually say it's not a big budget item to get started. There are tools, there are technologies, there are people that can help you get started for very low cost. Now, how far you can go at very low cost is maybe an open question, but you can get started. And I would encourage you to be experimental, to practice iterative, incremental development, to try things out, to see what works, what doesn't work. Again, assuming you've got the problem, you've got the data, and you've got the compute infrastructure and can use it, then you can get started pretty quickly. Ethics. I will say, of course, ethics matter in this space. There are interesting questions. I think going back to Jason's opening remarks, when you look at these machine learning capabilities that are becoming so popular, they can be attacked in interesting ways. They can have bias embedded in them that's hard to detect. They can compromise privacy in interesting ways. So I think ethics is a first order consideration as we roll out. There's no magic solution to this. I think we need very, very smart people thinking about the ethical implications of all of these technologies as we go. The technologies are going to be changing and advancing very quickly. So I think it's a constant battle. And then parting thoughts. I'll simply say I've been around these types of technologies for 25 years now. I'm an AI optimist. I think there is amazing opportunity to do great things, to change the world in very positive and impactful ways. And I less subscribe to the fear of AI. I largely think that comes from maybe not being completely informed about how these technologies work and what they're capable of. And so at least for the near term, I'm an optimist. I would promote the adoption of these technologies in a very smart and methodical way.
Okay, thanks, Jason.
Just to build off of what Matt said, I think if you use the tools that are frequently available open source, you can make a ton of headway really quickly. My only suggestion on top of that would be if it's an open source tool that you're expecting to be attacked, either build your own red team internally so that you can start to test your system against attacks, or take it to Matt at AFCEA, or take it to NIST, or take it to a national lab so that they can attack it for you. Because I think if we are building systems that are going to have intelligent attackers, the first thing they're going to try is looking at probably what open source code libraries you might have borrowed from that have already well-known attack surfaces. I think the opportunities for the United States to lead in AI ethics are really important. And I was really impressed by the DoD Defense Innovation Board's work on AI ethics. I think recognizing that for the United States to lead globally in AI, we will need to lead in AI ethics. for a number of reasons, but I think the most important of which is that the computer science community globally cares deeply about this and will move to the countries that care deeply about this. So if for no other reason than just the maintaining a strong workforce, this is something that we need to take seriously, in addition to all the reasons of finding principles that are resonant with our broader values. The only thing I want to close with is just gratitude that you all took time out to hear about AI. I know there's enormous interest in this topic, lots and lots of different sources of information. I'm just grateful to have been here in a panel that's so thoughtful about them.
Okay,
Thank you.
PT, take it home.
Okay, so I'm going to give from the government perspective, right? So these are academia and really smart, bright people. What does it take? So I'm going to give you, I think, something unique that I found out. Number one, go find a senior champion who truly believes that failure is okay, right? So what's missing for us is patience, right? What gets measured gets done. When was the last time you saw a senior executive write, hey, here are all the projects that I failed on, right? And if you don't find a champion that's willing to embrace failure, you will never see a person who embraces and who's passionate about AI, because you will never be successful in your first AI project. I've seen it, I've done it, I failed multiple times. I created the Big Data Award. The Big Data Award was the person who took the biggest risk and failed the biggest. And I gave them a 3-day time off award, and I did it publicly, right? Because we are a very risk-averse culture. And in the backdrop of having a rank-in person where you celebrate your success, this is not an environment that is conducive for that. So number one, I would start with finding a championship in which, if you're starting small, right, where failure is okay. Number two, I would, for the vendors, right, I would say stop speaking in system terms, start speaking in mission outcome terms, right? So when I hear questions like, hey, what's the best platform? What's the best, should I be using cloud computing? Or like, should I, you're not solving the problem, because your mission person, the vertical domain expertise that is needed, does not understand any of that stuff. I think number three is a technological shift has taken place. So think about, I remember this, it was a massive event at my house when King Charles or Prince Charles and Lady Diana got married. Everyone got up very early and it was a big event. Today, anyone can live stream from their Twitter account, right? So what cost millions of dollars today, or millions of dollars, 30 years ago, is very possible today, and because the adoption of services is capable, right? So in order to get started, as Matt, you said, it's very possible. But the harder part is not the technology, it's understanding the data and the cultural change of accepting patience that you cannot get to AI right away, because I am the recipient of the question that Matt asked. Hey, mission guys, I want to do machine learning and AI. What can you get me? But they cannot articulate the problem they're trying to solve.
Okay. Hey, are they amazing or what? Round of applause. Thank you so much. And we also finished a couple minutes early, so there.